So hey guys, today I'm going to explain about the probability program in Python language. And so this short program computes the probability of rolling a 4 on a 6-sided die, and which means 1 out of 6, and prints the result. I'll explain each line in a plain and simple language. So firstly here, for calculating the simple probability, we are taking a variable, creating a variable as total outcomes and set it to 6, which means a fair die has 6 possible faces, and that is 1, 2, 3, 4, 5 and 6. So there are 6 possible outcomes. Later we are taking another variable called as favorable outcomes, and we are setting it to 1, which is rolling a 4. This means that a fair die has 6 possible faces, right? And so this explains that only the face 4 counts as a success here. So there is only one favorable outcome. For example, if we roll a dice and there is only one chance of getting 4 in that dice, so after that comes the probability underscore 4, which is it will calculate the probability by dividing favorable outcomes by total outcomes. For example, the probabilities formula is favorable outcomes divided by total outcomes, right? So mathematically the probability is 1 by 6 here in this case. So the result is stored in the variable probability 4. In Python, this slash does floating point division, so the result becomes so the output will get as probability of rolling a 4 is 0.166666 and so on. So this will be the output for our program. And the last line, like this last line, will print a message to the screen. The F before the string makes an F string, that is formatted string, and the probability 4 is replaced with the value of that variable. So the program prints probability of rolling a 4 and gives this type of an answer. So for extra notes, as fraction the probability is 1 by 6, and as the percentage we can take it as 0.1666 so on into 100, which will come as 16.67%. So this assumes that the die is fair, which means it is not doing any partiality, and each face are equally likely. So that's it about the first part of this Python program, and then later we will see the applications of probability distributions to real life problems. That is, we are further calculating this program into normal distribution, and then Poisson distribution, as well as exponential distribution, and also we are going to see their outputs. Okay, so let's move on to the next step, that is normal distribution. Whereas here first we will import numpy as np, which means it loads numpy. It is the library that is used for numerical calculations or creating random data. And then we will import matplotlib pyplot matplotlib.pyplot as plt. It is used to draw the graphs and chats, for drawing those things. And then from skippy.stats we'll import norm, Poisson, binom and expon. These are the probability distribution concepts, like normal, Poisson, binomial and then exponential. So we will import these things. In this particular program we are mainly focusing on the normal distribution. And normal distribution, first let's understand what is the normal distribution. First Let us understand what do we mean by normal distribution and how it works, so that we can understand this program in a better way. And so chances are there that you have seen a normal distribution before, because it is also called a bell shaped curve, because it is a symmetrical curve, right? So that looks like a bell. So it is similarly looking like a bell. And in this particular example, the curve represents the human height measurement, because the normal distribution is usually used for measuring the height, weight, and things like that. And then here we have taken short, average height, and tall. So people can be short or average height or taller or anywhere in between these. So here x-axis represent the value itself, that is relative probability of observing someone who is really short or really tall or who has an average height. For example, it is relatively rare that we see very short people, and it is relatively very rare to see someone who is very tall, but it is very quite common to see someone who has an average height. That is why the curve here has spread out a lot, and it is an average height space. So this is all about normal distribution, and the mean here is this particular line here. It is also written like this. So this is how the mean is written, and it is also important for us to know about standard deviation, right? So the standard deviation. So knowing standard deviation is helpful because normal curves are drawn such that 95% of the measurement falls between plus or minus 2 standard deviations around the mean. And so here the standard deviation is represented as a sigma, and whenever the standard deviation is large, it is more likely that the curve is more flatter, and when the standard deviation is smaller, then we can see a taller curve that will appear. And so these are the two important characteristics of standard deviation. So to draw a normal distribution curve, we need to know two things. First point is that the average measurement. So the average measurement, this tells where the center curve goes. For example, where this center curve goes, it will tell us that thing. And second point is the standard deviation of measurements. So this will tell us how wide the center of the curve goes. For example, in this we can see how wide the center of the curve is going. So it is all about normal distribution and standard deviation. So let's go to the program and understand. So now that we have understood clearly about the normal distribution, its meaning and everything, we'll just go and see what this program is trying to do. And now that we have understood what these three lines are doing, let's move on further. So basically normal distribution is a quality control example, and now we will create a variable called mean, and we are setting it to 50. This is an average mean, and we set the standard deviation as 10. So the standard deviation is nothing but how spread out the values are, and then we are samples equals to np.random.normal. It means it simply generates 1000 random values that follow a normal distribution with mean 50 and standard deviation 10. These values actually simulate real measurements like product lengths in a factory. And then the next step is to plot an histogram. Here while plotting the histogram, we will set the size of the graph 8 by 6 inches, 8 inches by 6 inches. And then in the next step, plt dot hist, which means that we are taking bins as 30. It divides the data into 30 bars. Like when we draw a graph like this, and inside these bars are divided as 30, like 1, 2, 3 and 4, like this. It is like that. And then the density, it makes the bars represent probability and not just the counts. And alpha 0.6 is it will set the transparency, and color blue. The bars, I mean the line and the bars inside, everything will be in blue. And the next step is we will plot a normal curve. So from here we are plotting a normal curve where x equals to np dot linear space, or we can also write it as lin space, where we have taken this mean minus 4 into standard deviation, comma mean plus 4 into standard deviation, comma 100, which means it creates 100 evenly spaced x values from mean this one thing to this one thing. It will use this and create 100 evenly spaced x values, and this covers almost all the area of normal distribution. So in the next line, plt dot plot, where we have used r minus means the red line, and lw means it will make the line thicker, it will make it look thick. And then the label normal distribution, it gives the name for the legend. So next is the labels and display. Simply we'll give a title as normal distribution example quality control, and it sets the title of the graph. Next, label for x and y axis, where we'll give values for x label, y label probability density. And the next is plt dot legend, where it will show the label for the red curve. And then the plt dot grid, it will add grids behind the graph to make it look easier. For example, in the background it will add the grids like this. And then plt dot show, it will display the final combined graph on the screen. As you can see the output here, actually it is red. So here we can see that all the values are there. And so moving on to the exponential distribution example, I assume that these three lines you already know what it is. And the next, when we talk about this line exp underscore samples equal to np dot random dot exponential, it is also like creating 1000 random numbers, and then scale parameter is equal to 2, because it is equal to mean for exponential value. And then plt dot figure, it will draw, like it will put a canvas for the histogram and the line, and it creates a new it will create a new plotting figure with size 8 into 6 inches. And then the next line is plt dot hist. So here it will draw a histogram of the simulated samples, and other things are all similar to what we saw in the previous normal distribution example. And then here x underscore exp is the array. It will, like it is created for 100 evenly spaced x values from 0 to 10, and these x points are used to compute and draw the smooth theoretical pdf. Pdf means it is like probability density function. And then plt dot plot, It is like it will compute the theoretical PDF values of an exponential distribution at each x in x underscore exp. So next, this it's all about it adds the title and explains the example, and then labels of x and y axis, and then legend, grid, and show. So this is it about the exponential distribution.